Tiling solutions using reinforced polymer technology.
Norcross Adhesives is part of the Norcross Group, and alongside sister company Johnson Tiles, it is based at the heart of the UK ceramics industry in Stoke-on-Trent. The company is a leading British manufacturer. The product range includes branded adhesives, grouts and surface preparation products for fixing ceramic and porcelain tiles, mosaics, natural stone and marble. Quality is vital to Norcross Adhesives, so only the finest raw materials are used, along with increasing proportions of recycled materials. Strict quality control checks are performed on all incoming materials upon delivery. The modern, fully automated manufacturing and packaging plant employs lean manufacturing techniques for the high-volume production of polymer-modified powder adhesives, grouts and screeds, together with professional performance ready-mixed adhesives. Once the products are manufactured, the extensive care doesn't stop there. Each batch is individually tested, and high-tech machinery seals and palletizes each bag. Investment in state-of-the-art machinery at all stages of the production and packaging process enables Norcross Adhesives to manufacture, package and distribute technically advanced products within very precise manufacturing parameters, and with a minimum of wastage and environmental impact. Norcross Adhesives takes its environmental responsibilities seriously and is ISO 14001 accredited for reducing waste and improving resource efficiency. Norcross Adhesives continually refines and develops its product range, improving existing products and adding innovative new ones. The company's future growth comes through continued innovation and rigorous R&D to create the next generation of adhesives. This is the way Norcross Adhesives keeps one step ahead of its competitors. The company's recent investment in a new skills centre allows for the delivery of a wide range of practical courses for tilers and retailers, giving real insight into product development and installation techniques. In this way, investment by Norcross Adhesives is benefiting the industry as a whole. The Skills Centre enables Norcross Adhesives to deliver RIBA-accredited CPD courses, which are a welcome resource for architects, helping to drive up product knowledge and technical expertise within the industry. As well as theoretical training, students also get the chance to try out practical skills that they have learned. Exceptional training support is at the heart of the Norcross Job Done ethos. The Technical Helpline is a one-stop resource for advice and support on products, system installation and more. Site visits, technical reports and remedial advice are always available. All Norcross products come with a lifetime guarantee. It's the company's promise to the industry. It all adds up to a success story in manufacturing, sales and distribution for Norcross Adhesives. It is the one-stop shop for high-quality, British-made products.
Norcross Adhesives have formulated a new generation of tile adhesives and preparation products using reinforced polymer technology, or RPT for short. The incorporation of RPT gives the new S1 product range reinforced flexural and bond strength, as well as excellent crack bridging properties up to 3 mm. They also hold optimum thermal aging and anti-shrinkage properties, which are suitable for a bed depth of up to 10 mm. They're perfect solutions for challenging tiling environments, such as locations subject to thermal variation and substrate movement. The range also includes Norcross Tile to Gypsum adhesive, a fibre-reinforced anhydrite-based thin bed adhesive specifically designed for fixing tiles to gypsum or anhydrite screeds. The adhesive has a setting time of 2 hours at 20 degrees Celsius, permitting early trafficking of the tiled installation. It is suitable for use with underfloor heating systems too. Norcross Pro 50 levelling compound is a single-part fibre-reinforced self-smoothing floor underlayment which is suitable for use from 3 to 50 mm in one application without the need for additional granite chippings. It can also be used with under-tile heating systems and on strengthened timber floors. Learning aims and contents of this seminar. The aims of this seminar are to help you achieve an understanding of reinforced polymer technology in general, reinforced polymer technology in the development of tile adhesives and floor preparation products, the product features associated with RPT, installation environments which are ideal for products with RPT. We hope that when you've completed this seminar, you'll be able to identify the difference between RPT and natural fiber reinforcement technology, specify optimum products with RPT for demanding tiling situations. In this seminar, we'll cover these aspects. First, we'll give a brief overview of tile adhesive development to highlight modern challenges that tiling products have to overcome. Then we'll introduce you to the reinforced polymer technology and how it works by exploring fiber reinforcement technology and reinforced polymer technology in general, and the associated product features with the incorporation of RPT. Following on, we'll talk about the use of RPT in the development of tile adhesives and associated products. We'll explore the challenges of modern tile installations and how and why products with reinforced polymer technology can excel in these situations. First of all, let's look at a brief history of ceramic tile adhesive development in the UK. Originally, all tiles were fixed in a mixture of sand and cement. The first dust-pressed tiles in Great Britain were made in August 1840 by Messrs Minton and Boyle of Stoke-on-Trent, which became Messrs Minton Hollins Limited and later became one of the H&R Johnson Richards Tiles Limited group of companies. The first patent for the manufacture of Portland cement was taken out in 1842, and by 1850 there were around 4 small factories manufacturing Portland cement as we know it today. The fixing of ceramic tiles using a mixture of sand and Portland cement was well established by the end of the 19th century. The first British adhesive for fixing tiles was marketed by Minton Hollis Limited in 1936 under the name of Minto Mastic, but was forgotten by the end of the Second World War. In 1950, Richafix, a solvent-based adhesive, appeared on the market. This was the first adhesive in Europe to gain widespread adoption by tile fixers. Between 1950 and 1958, several other adhesives were marketed which were mainly solvent-based. After 1959, water-based adhesives containing organic materials such as natural and synthetic rubber, polyvinyl acetate, and various other resins came into prominence. These were known as mastic adhesives. In 1959, the first thin-bed cementitious adhesives based on Portland cement appeared on the market. Marketed under the name Ceramic Tile Fixing (CTF), various fillers and organic additives were used to allow thin-bed fixing to be achieved. Thin-bed fixing provides an adhesive bed of 2 to 6 mm beneath the tiles.
Saturday morning, and the young couple have already made a few simple preparations for the job. A strip of wood marked off with the exact spaces occupied by the tiles and a straight edge to form their baselines. Now the real fun can begin. Scoop out some of the ready-mixed tile set adhesive. Butter it onto the spreader. Start spreading. Not right up to the limit line, you see. You don't want any surplus oozing out beyond the tiles. See how smoothly and evenly the spreader works? And now comes the big moment, the laying of the first tile. Press it down gently but firmly into place. No complications and no mess with tile set adhesive and crystal tiles. Anyone can do it, and not only have fun while doing it, but also be sure of an exciting result. Next morning, the adhesive is dry enough to make it safe to remove the straight edge from the baseline in order to fix on the bottom row of tiles. For a narrow strip like this, it's best to put the adhesive onto the back of the tile itself, not on the wall. All is now ready to apply the grout, which has been mixed with water to a smooth paste. This is sponged firmly into the gaps between the tiles, thoroughly filling them, and gives the final touch of perfection to their appearance. Then, before the grout has had time to set hard on the surface of the tiles, the surplus is sponged away and finished off with a damp cloth. And there's the panel of crystal tiles, gleaming, hygienic, lastingly beautiful, and a really professional-looking job into the bargain.
Ever since, there has been ongoing development in the tile adhesive industry to improve products and to provide solutions for fixing ceramic and natural stone tiles, and in an evolving industry, porcelain and glass tiles of all shapes and sizes. Allow tiles to be fixed to a wide range of substrates and backgrounds such as timber, backboards, anhydrite screeds and metal, something not possible when sand cement fixing was the only option. Compared with sand cement mortar, tile adhesives provide much greater bond strengths, reduction of stresses imposed on tiles, for example they won't craze or crack, cleaner, quicker, easier fixing of tiles, elimination of need to soak the tiles prior to fixing, controlled formula using pre-selected and specified raw materials. Originally, the type and size of tiles being used was limited. For example, quarry tiles were available in sizes of 150 by 150 mm and 200 by 200 mm, and glazed biscuit body tiles available in 100 by 100 mm and 150 by 150 mm, fixed onto mainly concrete or cement sand screeds and renders. In these circumstances, fixing in basic adhesives would have been more than adequate and a big improvement on the basic sand cement fixing method. However, things have progressed, and the ceramic tile adhesive is now required to fix an ever-increasing range of tiles, ceramic, porcelain, glass, natural stone of all shapes or sizes, to a wide range of substrates and backgrounds. Some not deemed suitable to receive a tiled finish a few years ago, or in some cases, not even invented. Tile size is a major issue, as tiles as large as 2 meters by 2 meters are now being specified. Advancements in construction mean that we see a much wider range of substrates and backgrounds, such as timber, underfloor heating, plasterboard, tile backer boards, anhydrite screeds, epoxy coatings, acoustic floor systems, glass reinforced plastic, steel. To cope with the ever-increasing demands imposed by the vast array of tiles and substrates, it is essential that investment in the research and development of ceramic tile adhesives and other related products continues. The advancements in fiber reinforcement and polymer technologies have played a major role in the ongoing development of tile fixing products, and will continue to do so. It is down to the tile adhesive manufacturer to make the most of technologies on offer. For example, in the London Underground, the adhesives must provide very high bond strengths, not only to cope with the movement and vibration, but also to prevent tiles from being pulled away from the background by the vacuum created by the trains. Common fiber-reinforced composites are composed of fibers and a matrix. Fibers provide the reinforcement and main source of strength, while the matrix glues all the fibers together in shape and transfers stresses between the reinforcing fibers. Fiber reinforcement usually adds rigidity and greatly impedes crack propagation in the composite material. Thin fibers can have very high strength, and provided they are mechanically well attached to the matrix, they can greatly improve the composite's overall properties. Fiber-reinforced composite materials have gained popularity in high-performance products. These materials fully control the high-technology era we live in to such an extent that it has become impossible to live the life as we know it now without these products. Industries that have utilized fiber-reinforced materials include aerospace, clothing, medical, motor manufacturing, building, packaging, and many more. For example, in construction, fiber-reinforced concrete contains fibrous material, which increases its structural integrity. Fibers are usually used in concrete to control cracking due to plastic shrinkage and drying shrinkage. They also reduce the permeability of concrete and thus reduce water ingress. In fibre-reinforced screed, polypropylene fibres, referred to as PP fibres, are combined with the sand and cement screed and thoroughly dispersed during the mixing process. The use of fibres inhibits shrinkage, settlement cracking, increases strength, permeability, and is more impact resistant. The use of fibres in construction is not a new idea. Fibres have been used in wattle and daub and lime horsehair plaster. RPT has brought these traditional methods into the modern-day era. The fibres used in this technology are synthetic fibres made from propylene monomers, and the technology also contains a high redispersible polymer content. The key element is the length of these strands, which helps push product performances even further than other types of fibre. As an example, you will see a rib of tile adhesive zoomed in to expose the polymer fibres embedded in the cementitious matrix. Reinforced polymer technology has a structure built up chiefly from a large number of similar units bonded together to get the correct interactions from the polymer chains within the tile adhesive formulations. The fibres used in this technology are synthetic fibres made from propylene monomers, and the technology also contains a high redispersible polymer content. The key element is the length of these strands, which helps push product performances even further than other types of fibre. As an example, you will see a rib of tile adhesive zoomed in to expose the polymer fibres embedded in the cementitious matrix. Reinforced polymer technology has a structure built up chiefly from a large number of similar units bonded together to get the correct interactions from the polymer chains within the tile adhesive formulations. Products incorporated with polymer fibres often deliver additional features such as shrinkage control, crack control, increased flexural strength, impact protection, pot life. The reinforced polymer technology enables a huge step forward in the development of tile adhesives and associated floor preparation products such as leveling compounds. Before we go into how reinforced polymer technology contributes to the development of tile adhesives and associated products, we'd first like to recap the industry classification which you may be aware of. BSEN 12004 Adhesives for Tiles, Definitions and Specifications is the current industry standard. C indicates cement-based tile adhesive. D is for dispersion-based or ready mixed. R denotes reaction resin-based. These are further subdivided into 1 for normal adhesive, 2 for improved adhesive. This is for additional tensile strength, which is generally a high polymer modified product. E for extended open time, F for fast setting, T for reduced slip, S for transverse deformation, which is defined in BSEN 12002. This is a measurement of how much the adhesive or grout is able to distort under stress. S1 equals 2.5 to 5 mm, S2 equals greater than 5 mm. Although fibre-reinforced products are already in existence in tile adhesive manufacturing, the incorporation of synthetic polymer strands is a first in the industry and can offer specific product features such as reinforced flexural and bond strength, crack bridging property up to 3 mm, extended open time. With increased level of polymer fibre, these tile adhesives can typically achieve BSEN 12004 C2 for improved formulation, E for extended open time, and S1 for transverse deformation of between 2.5 and 5 mm. S2 for high deformability of 5 mm and over can also be achieved with some products. These features apply to both standard setting and fast setting products. Today, tile to gypsum adhesives are available in the marketplace. They are gypsum-based and specifically designed for tiling onto anhydrite and calcium sulfate screed. Reinforced polymer technology is incorporated into this type of adhesive too, typically bringing the product to a BSEN 12004 S1 type, denoting transverse deformation of between 2.5 to 5 mm. Apart from increased flexural strength, extended open time, and crack bridging properties. Fiber reinforcement is often seen in floor leveling products. Reinforced polymer technology again further increases the product's flexural strength, crack bridging, and thermal aging properties. To summarize, earlier we mentioned that other fiber reinforcement is already being used in the manufacturing of ceramic tile adhesives and other associated products. Cellulose is commonly used in ceramic tile adhesives to help with water retention for curing, and there are nylon-type fibers being used. These are called natural fibers. Compared with reinforcement with natural fibers such as cellulose, tile adhesives and leveling compounds with reinforced polymer technology tend to exhibit the additional properties of crack bridging and deeper bed deflection, amongst other improvements which we will explore in more depth by product category later. In previous sections, we've introduced the history of early tile adhesive development, the modern technology of fiber reinforcement, and especially reinforced polymer technology in the improvement of tile adhesives and associated products. In this section, we'd like to explore the challenges of modern tile installations and how or why products with reinforced polymer technology can excel in these situations. Generally, prior to installation, it must be ensured that the substrate is suitable for the surface conditions to which it will be exposed. Adequate surface preparation of the substrate is important. BS 5385 parts 1 to 5 gives the following guidance for tolerances on finished floor level. When checked with a 2 meter straight edge with 3 mm feet at each end, any gap underneath the straight edge between points of contact should not exceed 3 mm. The maximum deviation between the surfaces either side of a grout or movement joint should be 1 mm for joints less than 6 mm wide and 2 mm for joints 6 mm or greater in width. The recommended drying times for construction substrates are also essential. References can be sought on requirements in BS 5385 parts 1 to 5. The substrate must be stable and rigid, and in the case of floors be capable of taking the weight of tiling together with any trafficking imposed upon it without excessive movement or deflection. BS 8204 Part 1 gives recommendations on screed testing. The maximum weight limit for tiling to a wall background must also be established. Substrate, especially sheets and board substrates, must be dimensionally stable even under changing moisture or thermal conditions. Stresses may arise from various substrate movements, such as deflection. This could happen with a timber substrate if it's not been prepared to ensure that it's sufficiently stable and rigid. Thermal or moisture movement. Changing thermal and moisture conditions such as underfloor heating or wet room installations can cause the substrate to expand and contract, which may result in tile or grout cracking. Drying shrinkage of the screed can also lead to loss of adhesion and bulging or cracking of the tiling. Chemical formation. For example, ettringite is formed as a reaction between hydrated Portland cement and calcium aluminate within an anhydrite or calcium sulfate screed. Its crystallized formation can affect the structure of the cement, thus resulting in a weakening or breakdown within any cement-containing adhesive. The substrate must be capable of supporting the tiled weight. Any type of dynamic or static loads and impacts the tiled installation may be subjected to. Floors where deflection is anticipated should be strengthened before the commencement of tiling. The specification of cementitious tile adhesives with reinforced polymer technology will protect tiles against some minimal deflection movement due to their increased flexibility, transverse deformation of between 2.5 to 5 mm and crack bridging properties. Materials expand and contract under the influence of heat and moisture, such as tiled installations with underfloor heating or a wet room or changing room installation. Excessive movement can occur between the tile and the substrate due to different rates of expansion and contraction. The main consideration for tiling specification here is to ensure that the adhesive is capable of withstanding the excessive movement. In general, a polymer-modified cement-based adhesive conforming to BSEN 12004 C2 classification should be selected. However, the specification of cementitious tile adhesives with reinforced polymer technology again can offer increased flexibility. transverse deformation of between 2.5 to 5 mm, crack bridging up to 3 mm, and optimum thermal aging properties, thus providing a belt and braces approach. As concrete or cement-based mortar dries out, moisture within it is reduced and shrinkage will occur. Stress is then built up in the layers, which can lead to debonding between the tile and adhesive, or the adhesive and substrate. Often with screed shrinkage, the tile can no longer fit in the original space, resulting in tenting or bulging of the tile. BS 5385 outlines the guidance on drying times to reduce the drying shrinkage stresses associated with constructional substrates. There are fast-drying, low-shrinkage cements, which can be used rather than Portland cement into screeds and renders to reduce shrinkage. Adhesives with reinforced polymer technology, due to their increased flexibility and crack bridging properties, help absorb and withstand the stress caused by drying shrinkage. It should be noted, however, that the use of these adhesives does not replace the requirement of movement joints. Ettringite is an expansile crystalline material formed as a reaction between hydrated Portland cement and calcium sulfate. Ettringite is a crystalline form of calcium aluminosulfate. It can affect the microcrystalline structure of the cement, thus resulting in a weakening or breakdown within any cement-containing adhesive. Gypsum, calcium sulfate or anhydrite-based screeds are based on a binder of calcium sulfate rather than cement. Generally, they can be pump-applied and therefore faster to install than conventional cement-based screeds, resulting in a growth in the popularity of their use, especially when used with underfloor heating systems. Traditionally, when tiling to gypsum-based screeds, precautions would need to be taken with surface preparation, such as moisture content. Unlike cement-based materials which can remain strong even when wet, gypsum-based materials gain strength by a process of crystallization, and so must be fully dry before covering. BS 5385 requires the screed to dry to 0.5% or less water by weight as measured by the carbide bomb method, or less than 75% relative humidity as determined by a hygrometer. Higher than 0.5% water by weight, more than 75% relative humidity, will greatly increase the risk of ettringite formation. Surface latents. Many gypsum-based screeds form a weak surface layer, which must be mechanically removed before tiling, for example by grinding. Sealing or priming. To cut down the risk of ettringite formation, it is important to prime or seal the screed before the application of cementitious tile adhesives. The modern tile to gypsum with reinforced polymer technology can significantly cut down the time of the preparation process onto gypsum-based screeds. Such an adhesive is gypsum-based, hence no risk of any chemical reaction between the cement and calcium sulfate. No heavy sanding or sealing is required, and tiles and stone can be fixed onto gypsum-based substrates with a relative humidity of up to 85%. 2 to 3 hour rapid setting options are available. Floor leveling compounds are based on polymer-modified cement with high flow characteristics. They are typically installed over an existing subfloor to level and correct any surface irregularities prior to the installation of all types of interior floor coverings. These floor underlayments have increased in popularity as the degree of flatness and smoothness required for floor covering products has increased, with vinyl products becoming thinner and floor tiles becoming larger, for example. With the addition of reinforced polymer technology, self-leveling compounds exhibit improved flexibility and crack bridging properties. Such a leveler may be suitable for use up to 50 mm in one application without the need for additional granite chippings. It is ideal for use with underfloor heating systems, where it may be used to cover the wired elements, providing a level substrate to tile and also protecting the heating elements during the fixing process. Without the adoption of RPT, levelers over 10 mm could crack, shrink, and debond. Let's summarize what we've learned today. By now, you'll have achieved a necessary understanding of fiber reinforcement and especially reinforced polymer technology in the development of ceramic tile adhesives and associated products. You'll have found that reinforced polymer technology has recently pushed the development of tile adhesives and floor leveling products a step forward. RPT tiling products in general exhibit increased flexural strength, excellent crack bridging and optimum thermal aging properties. Therefore, they excel in tiling projects with demanding situations such as heavy loads or traffic, timber substrates and underfloor heating. The specification of RPT products can add quality assurance to projects and bring peace of mind to clients. Here's just a short list of further references. Norcross Adhesives are always happy to provide specification support and advice at any stage of a project. Should you require any further information on any aspect we've spoken about in this seminar, please contact our specification advice line on 0870 609 2851 or email technical@norcross-adhesives.com.